Welcome to SS2 Computer Science, Term 3, Week 7. Database normalization is the process of organizing a relational database to reduce data redundancy, repetition, and improve data integrity. A poorly designed database wastes storage, makes updates difficult, and can introduce inconsistencies. Normalization provides a systematic method for producing good database designs. By the end of this lesson, you will define normalization and explain its purpose, understand primary keys, foreign keys, and functional dependencies, apply the first three normal forms, 1 nanofarad, 2 nanofarads, 3 nanofarads, to convert a poorly designed table, and answer WAEC questions on database design and normalization. Let us begin. Consider a poorly designed database table for a school: student course grades table, student ID, student name, course ID, course name, teacher name, grade. Problems with this design: data redundancy. If student Chidi takes 5 courses, Chidi Okoro is stored 5 times. If the spelling changes, all 5 rows must be updated, or inconsistency results. Update anomaly. If teacher name for course name changes, every row containing that course must be updated, miss even one row and the database is inconsistent. Insertion anomaly. You cannot add a new course to the system until at least one student enrolls. The table requires a student. Deletion anomaly. If the last student drops a course, the course information is lost from the database. These anomalies indicate bad design. Normalization eliminates them. Key concepts: primary key, a column, or combination of columns, that uniquely identifies each row in a table, must be unique, must not be null. Example: student ID uniquely identifies a student. Composite primary key, a primary key made of 2 or more columns. Example: student ID, course ID, uniquely identifies a student course enrollment. Foreign key, a column in one table that references the primary key of another table, establishes relationships between tables. Functional dependency, attribute B is functionally dependent on attribute A, written a B, if for each value of A, there is exactly one value of B. Example: student ID, student name. Knowing the student ID, you know exactly one student name. First normal form, 1 nanofarad. A table is in 1 nanofarad if each column contains only atomic, indivisible values, no list, no sets, no repeating groups in a single cell. Each column contains values of a single type. Each row is unique. There is a primary key. What violates 1 nanofarad? Repeating groups, order ID, product name 2, product name 3, multiple values in separate product columns. Multivalued attributes, order ID, products, pen, book, ruler, and a list in one cell. To convert to 1 nanofarad, replace repeating groups with a separate row for each value. Example: unnormalized table, order ID, customer name, products. 1001 Chidi pen, book. 1002 Emeka ruler. Convert to 1 nanofarad, create a separate row for each product, order ID, customer name, product. 1001 Chidi pen. 1001 Chidi book. 1002 Emeka ruler. Now each cell contains one atomic value. Primary key for this table, order ID, product, composite key. 1 nanofarad row summary, atomic values, single type per column, unique rows, primary key exist. Second normal form, 2 nanofarads. A table is in 2 nanofarads if it is already in 1 nanofarad and every non-key attribute is fully functionally dependent on the entire primary key, not just part of it. This only applies when the primary key is composite, 2 or more columns. If the primary key is a single column, 2 nanofarads is automatically satisfied if 1 nanofarad is satisfied. Partial dependency, a non-key attribute depends on only part of the composite primary key. This violates 2 nanofarads. Example: 1 nanofarad table, order ID, product, customer name, product price. Primary key, order ID, product, composite. Functional dependencies, order ID, product, both needed to determine. Customer name, order ID, customer name depends on only order ID, not the full key. Partial dependency, product price, product price depends on only product, partial dependency. To fix, convert to 2 nanofarads, split into separate tables, orders table, order ID, PK, customer name, order ID customer name, no partial dependency. Products table, product, PK, product price, product price. Order details table, order ID, FK, product, FK, quantity, both columns needed for the key. Third normal form, 3 nanofarads. A table is in 3 nanofarads if it is already in 2 nanofarads and there are no transitive dependencies. A non-key attribute depends on another non-key attribute. Transitive dependency, a BECE where B is not a key, C is transitively dependent on A through B. Example 2 nanofarads table, student ID, PK, student name, course ID, course name, teacher ID, teacher name. Here, student ID, course ID, student takes a course ID, course name, course has a name, course ID, teacher ID, course has a teacher ID, teacher name depends on teacher ID, non-key, which depends on student ID. This is a transitive dependency. Fix, convert to 3 nanofarad students, student ID, PK, student name, course ID, FK. Courses, course ID, PK, course name, teacher ID, FK. Teachers, teacher ID, PK, teacher name. Enrollments, student ID, FK, course ID, FK, grade. Summary of normal forms, 1 nanofarad, atomic values, no repeating groups, primary key exist. 2 nanofarads, 1 nanofarad plus no partial dependencies, all non-key attributes depend on the full primary key. 3 nanofarads, 2 nanofarads plus no transitive dependencies, non-key attributes depend only on the primary key, not on other non-key attributes. Benefits of normalization, eliminates redundancy, data stored only once, save storage, eliminates update anomalies, update in one place, consistent everywhere, eliminates insertion anomalies, can add data independently, eliminates deletion anomalies, deleting one fact doesn't accidentally delete another. Disadvantages of overnormalization, denormalization. More tables mean more join operations in queries, slower queries, for read-heavy applications, like data warehousing/analytics, sometimes some redundancy is deliberately introduced, denormalization, to speed up reads at the cost of some update complexity. Keys review, primary key, uniquely identifies each row, not null, not duplicate. Foreign key, references primary key of another table, establishes referential integrity. You cannot have a foreign key value that doesn't exist in the reference table. WAEC examination questions on normalization, define normalization and state its purpose, define 1 nanofarad, 2 nanofarads, 3 nanofarads, convert a given unnormalized table to 1 nanofarad, identify a partial dependency in a table and convert to 2 nanofarads, identify a transitive dependency and convert to 3 nanofarads, state the benefits of normalization, define primary key, foreign key, composite key, functional dependency. Key points, normalization, process of organizing tables to reduce redundancy and anomalies. Anomalies, update anomaly, must update many rows, insertion anomaly, cannot insert without other data, deletion anomaly, lose data when deleting. Functional dependency, a B means knowing A gives exactly one B, primary key, uniquely identifies each row, composite key, 2+ columns as key. 1 nanofarad, atomic values, no repeating groups, primary key exist. 2 nanofarads, 1 nanofarad plus no partial dependencies, applies when composite key. Partial dependency, non-key attribute depends on part of composite key. 3 nanofarads, 2 nanofarads plus no transitive dependencies. Transitive dependency, non-key attribute depends on another non-key attribute. Fix for partial/transitive dependency, decompose into separate tables with foreign key relationships. Benefits, no redundancy, no anomalies, data integrity. WAEC, identify the normal form of a given table, find violations, decompose tables step by step, define key terms.